Welcome to the Economic Geology class. In the previous lecture, we have studied about the details of the syllabus that we have in this paper. We studied about the concept of ore, we understood their definitions in detail, what ore deposits are, what ore minerals are, what gangue minerals are, and what are the tenor of ores. So, in this lecture, we will go in the details of the concept of ore. Sorry. So, here you are seeing a world map which is showing the presence of various elements, or I should say metals. See, iron, gold and other elements are seen spread all over the world in different places. For example, gold here has a geochemical anomaly. It is not present all over in this region, but it is present only in this region. You must have seen different metallic and non-metallic mineral ores map also in the junior classes. In the atlas, you have it everywhere. So, how are these related to geology? We will try to understand that. As we saw here, there are various elements which are seen within the continental regions. These continental regions are parts of some plates, because only these have been explored so far. We haven't been to the depths of oceans, although we have seen many of the oceanic, mid-oceanic margins, but still the exploration is on. So, on the basis of that, we know about various occurrences of ores within the world. So, let us try to understand that how these economic minerals, that is ores, are related to the plates. These are different plates present in the earth, be it the Eurasian, African, Indo-Australian or Antarctic plate. You know about all this. So, in some places, these plates are subducting. In some places, they are going away from each other. In some places, they are coming towards each other. These are peculiar regions of subduction where active volcanoes are present. These active volcanoes, they bring lava to the surface. Means they are bringing various elements present below the surface of the earth to the surface of the earth. So, if we try to understand it this way, that the magma rises, it comes on the surface where the plates get separated from each other. For example, it may be in the mid-oceanic ridge, or the crust goes beneath the other crust, and due to partial melting, it produces a different type of magma which has a different composition in relation to this, relative to this, and this magma then it comes back with a different composition. Okay, these compositions are the mineral compositions, because we know that ore is nothing but a rock which has different minerals which can be extracted profitably. So, you may get minerals here, you may get minerals here, economically viable minerals. So, here I am giving few of the example of the minerals which are present in reference to the plate margins or plate convergence and separation. So, in the mid-oceanic ridges, you find a lot of iron, copper, zinc sulfides, including chromium also. Within the sea floor, you get manganese nodules. In the four arc basin, a basin which is developed in the frontal part of the mountain due to subduction, a four arc basin. In this, you find various lead, zinc, and copper deposits. Whereas in the magmatic arc, this is a chain of volcanoes which forms due to the subduction, which produces magma in return, and it comes out as a mixed magma or an intermediate magma here. So it may have porphyry deposits, gold, silver, copper, lead, and other metals. So the presence of this geochemical anomaly, that is the ore, is always related to plates, their separation, their convergence. Okay, so we'll study about the formation of ores in detail in the second unit. How are these formed? This is about the occurrence. We get these ores spatially all over the earth in different places. They occur due to some specific reasons related to the separation and convergence of plates. There are different processes which govern their formation. We will study this in unit 2. So if we look at this example, this is the diagrammatic representation of what you have just seen here in this block diagram. Wherever the plates are going apart from each other, rift zones are formed. These rift zones are usually rich in metal-rich brines. They form places where metals may be found. And in some places where rifting slowly ceases, here also you may find lead, zinc. Coming to the passive margins, the margins which are not active, here also you may find lead, zinc and gold. Coming to the back arc basins, here you may find copper, iron. Wherever you are finding lead and zinc and silver, you also find gold there. In oceanic arcs, you may find copper and gold. In mid-oceanic regions, you may find chromium, copper, iron. Going away from the mid-oceanic regions, copper, nickel, cobalt, and as you go again towards the continental part, as we already discussed, you may find gold, copper, molybdenum, etc. Okay, so depending upon the plate margins or the interaction of the plates, you get the occurrence of various minerals. So the plate tectonic scenario is what controls the presence of various economic minerals. So let me introduce you to a new word, ophiolite. Ophiolites are found in the mid-oceanic ridges, okay, in this region. So these are the places where you get a complete sequence of different rocks. Here you may find various economically important minerals. As this material moves towards the continental margin, this may abduct and come out here like it is shown here, the way it is happening in Himalayas near the Indus-Sangpo suture zone. So here you get various elements which are economically useful to us. Okay, so we will go into these details as we keep studying the different units ahead. I am just trying to give you an example of how major ores may be formed. There are various other processes also which are related to the major processes, magmatic processes, or the sedimentary processes, or the geochemical processes. So if we see the magmatic process, as the material, as the magma comes towards the surface of the earth, it may cool, and here it brings solutions which are rich in minerals. As these come to the surface, they get cooled, so they slowly get deposited here. The way it is seen happening here in the black smokers. This photograph is of a black smoker. This is not a simple smoke, it has various minerals within it which slowly get deposited and form structures like this. These are rich in sulfide ores. So the condition will be something like this, where various organisms thrive. The black smokers, they bring various minerals like this. They may be white smokers depending upon the composition of the material that they are bringing from underneath, or they may be black. Okay, these are rich in nutrients. Because of these nutrients only, various organisms thrive in these regions. So you may get, if you see a cross section of the black smoker, you may get various sulfides. In the other case, the minerals may form due to cooling of the magma also directly. The magma cools due to fractional crystallization depending upon the Bowen reaction series. Some minerals, they crystallize, they fractionate and get deposited as cumulates. For example, olivine may form first. After that, the other rocks will form, other minerals will form. Olivine, then pyroxene, then amphibole, and then slowly, finally, quartz will form. You have studied this in the Bowen reaction series. So likewise, you may get layers of different minerals. Okay, and the residue, that is the material which is left over, that is known as the residual magma. So from the residual magma, the rock which is formed, that may be constituting of various economically important minerals, among which chromite is very important. Okay, so these are different processes due to which minerals may be formed. So we are discussing magmatic processes as of now. So you get the olivine crystals or spinel crystals like this. Coming to the chemical processes, the climate is also responsible many a times. If you see this region, here is the mine. This is the bauxite ore which is formed due to the weathering of this rock type here. Okay. So bauxite is a ore of aluminium. It slowly gets weathered, it may slowly form kaolin and then go to gibbsite. So chemical conditions also form ores. Like we see here, the ore of calciums can also be there. You have seen such speleothems in the field when you went to Patal Bhubaneswar. I hope you all remember that. There may be mechanical processes also which form ore. You have disseminated presence of minerals. Try to concentrate them. This becomes the ore then. Okay. So for mechanical processes, what you need to do is remove specific minerals or remove specific elements from a rock, transport them and concentrate them. Say for example, if magma came, cooled and then formed various sulfide deposits here, they may be present in this region. From here, the rivers, they erode the material, they bring it downstream. So we may get different ores in the streams also, right? The way it is shown here, the hydrothermal veins, they have brought some of the sulfide ores to the surface, and then they are getting weathered and eroded, and then we get them in the placer deposits. We will study about this in detail. So what we can do is we can extract these ores from the placer deposits. We can do panning here, and what we get is nuggets of gold if we are lucky enough and if we have done good prospecting. So thank you for this patience which you took while studying all this. You're free to ask questions. We have today discussed the formation of ores. We will study about the detail of the processes which are responsible for this formation in different units. In this lecture, I have tried to give you the broad overview of how economic minerals are seen spread all over the world and how they are related to the plates, and also how various ores may form due to magmatic, mechanical and chemical processes. Please feel free to ask questions. Thank you so much.